Perfect. Thank you, everyone, for joining gdg certification series, Road to Google Developer Certification, which is focused on machine learning. My name is Preeti, and I'm the organizer for GDG Surrey chapter. We are a welcoming community where developers and tech enthusiasts from all walks of life gather to connect. Whether you are a student or a professional, you come from the healthcare sector, it does not matter. As long as you're interested in machine learning, this series is for you. Our mission extends beyond just technology. Excuse me. It's about empowering each other to imagine, innovate, and make a meaningful impact. So if you have any suggestions for our future sessions, please let us know. If you have any idea that you think you need a group to start with, or you just don't know where to get started from, let us know. Send us email, or on LinkedIn or Discord. Just connect with us, and we are there for you. Now, moving on to the next slide. Okay. So the road to Google Developer Certification, as I mentioned, today we are excited to focus on this particular certification series session for one more time. This is focused on professional machine learning certification. This initiative is designed to elevate your skills in Google Cloud technologies and machine learning. This does not guarantee that you would really make it through the certification. You still need to plan your hours. You need to focus on self-study, and you need to practice. And if there are any challenges that you face with the labs, or you want your questions answered because some key concepts is missing, then just let us know. We'll get in touch with the experts and we'll get those answers for you. Now, here is the GDG Surrey steering team. Now, let's take this moment to appreciate the GDG Surrey steering team, whose dedication and hard work make these events possible. Okay, thank you so much, GDG Seattle, for this collaboration. We are thrilled to collaborate with GDG Seattle for this series, bringing together the best instructors and experts in the field. This partnership helps us ensure you receive top-notch guidance and support as you prepare for the certification. GDG Seattle team's expertise and support have been invaluable in making the certification series more meaningful. And we have Margaret here from GDG Seattle today.
Hello.
Okay, just a recap here for those who missed the sessions by our instructors. The sessions provided a detailed overview of what to expect in each session of our certification series. If you couldn't attend, the session is available on YouTube, and the link will be shared and is already shared in the chat and on our Discord channel. Also, if you navigate to our official GDG Surrey chapter page, in the description towards the end, you have a YouTube link where you can find all the videos. If you go to past events on the on the official channel, official chapter, again in the past events you have the videos already present there with the slides that we share. And if you couldn't find, just let us know on the Discord. All righty, so the moment that we have been waiting for today. I'll go ahead with Margaret as she'll be she'll be taking the lead for the session, starting the computer vision. So Margaret is an machine learning engineer experienced in applying machine learning to real-world use cases in art and design. She's recognized as Google Developer Expert in artificial intelligence and machine learning. She's a contributor to open source projects, writes and speaks about generative AI, on-device ML, art and design. She's also a 3D fashion designer, and we can say she's an artist creating traditional, digital, and AI art. I recommend really checking out her LinkedIn and check out her last week's posts. They're amazing. So over to you, Margaret, and next we'll go with Vikram.
Great. Thank you, 𝗏𝗏, for the intro. I'm just sharing my screen now. Okay, everyone can see, yes?
Yes.
All right. Well, 𝗏𝗏 has already gone through the intro, and so in this session, we will go over the courses, like a refresher of the courses, but also our own, some of our insights and problem solving. And feel free to ask questions in the chat, and we will answer the questions in the end. We have live moderators who will also respond to your questions. And also, 𝗏𝗏, is there Slido where they can
Yes.
answer questions? Yeah. Do you have the link you will enter to the chat?
Just did.
Okay. All right. So while you're doing that, today is session 4, where we will go over the, Vikram will go over the production ML systems. I will cover the computer vision fundamentals with Google Cloud. I was here the very first session, February 24th. And back then, you know, on that day, I gave an intro to AI and the machine learning on Google Cloud. So if some of you joined then, it's great to see you today. And also very excited to see those of you who recently joined our study session, the group session. And it's a like I will be covering the computer vision part, and then the Vikram will cover the production ML part. And what I will do is I will it's a short talk, a bit of a review of what the Google Cloud Skills Boost covers, but also some of my own insight and experience. So yeah, computer vision on Google Cloud. I am very excited about the topic, by the way, computer vision. I know today you hear a lot about large language models and, you know, generative AI, etc. For me, I have always been excited about computer vision. I'm still excited about computer vision. And for me, generative AI, the very important part is what it gets generated. And I'm most interested in the visual part, you know, like the images and the video, etc. The large language models is just a way of enabling that, but enabling like prompt to say what you want to generate, etc. But the computer vision, you know, the visual part is what I'm most interested in. As 𝗏𝗏 mentioned earlier, I am a GDG Seattle organizer, and thank 𝗏𝗏 for your collaboration for this study series. I'm a MLGDE and a 3D artist and fashion designer. My area of expertise is generative AI, computer vision, and on-device machine learning, and I do talk a lot about art and design. And in the spring quarter next week, I will also be teaching an AI class at University of Washington, which I'm pretty excited about as well. So first, I'm going to talk about the course on the Google Cloud Skills Boost. How many of you already taking the class? Ideally, you have already taken the classes before you come. So you can respond to that in the chat. Like, how many of you? Okay. So it's great if you have taken the class. I'm just kind of reviewing what the class has covered and add a little bit extra. But if you haven't taken the course yet, this will be like a brief overview before you dive into taking the class and the concepts. Okay, so April said you are at the beginning. Okay, great. So whether you already completed the course or you just haven't started, it's good that, you know, I'm giving an overview. The course has 5 modules. The first module gives like an intro to computer vision, what it is, and some use cases, etc. And then module 2 talks about Vertex AI and Auto ML Vision, which is the services that Google Cloud provides for solving computer vision problems. And module 3 covers custom training, and module 4 goes into convolutional neural network. And then module 5 talks about working with image data. And module 1, as I said, it's Intro to Computer Vision. It covers what is computer vision and different types of computer vision cases, and the various ML tools on Google Cloud, and experiment pre-built APIs using the hands-on labs, right? I'm gonna skip all those details, since you can look at the details on the Google Cloud Skills Boost. But I'm going to talk about the computer vision use cases here, in particular in art and design. Well, some of the use cases, right? First, you can classify an image, which is a very basic task. A lot of times you learn about hello world in AI, machine learning, CNN. The first one, typically start with a classification there. And you basically classify an image to a particular class. And the first example, for example, here's a Van Gogh painting. You could classify, okay, what is the painting style or artist? But then you're looking at the entire image, right? And give it a label. And the second example could be multi-label in image classification. For example, a movie poster genre, it could have multiple genre, right? This Matrix movie, it's action, and it could also be sci-fi, right? And then feature extraction, you extract the latent features of an image with you could use CNN model. And then once you extract these features, you can perform a visual search on it. And later on, I'll briefly mention the labs, like the first lab. And by having these features, like on Google image search, you give it an image and you can do an image search. That's actually under the hood, what powers it is these feature vectors. And then another computer vision use case would be object detection, to identify one or more objects within an image and their locations, and you draw a bounding box. So here I include an image of detecting UI elements in a UI asset. Right? And then segmentation, you classify whether each pixel of the image belongs to a certain class. You can have instance segmentation or semantic segmentation. And then finally, the generative models. Before, typically, we have used computer vision, and today we have computer vision plus NLP, multimodal. And you can generate new images, you can increase image resolution, you can do image-to-image translation, you change or transfer, or the kind of the style of the image, or text to image generation, which is quite popular these days. In module 1, there are 2 labs. The first lab is to use the Cloud Vision API to detect the labels, faces, and landmarks. If you have not done it yet, the basic step is you create a bucket on Google Cloud, and you upload an image, you enable it to be public access, and you send a JSON request to the Cloud Vision API, and then you receive a JSON response. And in the lab, you just look at the response in the raw JSON response. But if you were to build an application, right, you could be on the phone sending an image. Sorry, phone may not be a good example, because if it's on the phone, hopefully you are running the inference directly on your phone. But through, say, a web application, right, you send the image over, you get the JSON request response back, and then you parse that response, and then you will create some sort of UI to show that response, right? Depending on what you are trying to do, whether it's detect the labels, faces, or landmark, etc. And then the second lab is to extract text from the images using the Google Cloud Vision API. There you extract the text and translate and then the save text to Google Cloud Storage. So those are the two labs for Module 1. And then in Module 2, you get an intro to Vertex AI, Google's unified AI platform. It also talks about, why Vertex AI is important, what it is, and then talks about how to automate an ML pipeline with AutoML, and then intro to AutoML vision, and then gives an example. And then finally, it helps you. The course will talk about how do you decide between vision and API, AutoML vision versus custom training. Well, all of these, it's all depending on your use case and scenario, whether you want a simple solution, less coding, or more custom solution, more control over what you want to do. And Module 3 starts with image classification. As I said, image classification is the most basic example for getting started with learning neural networks. And then you will learn about how to train a custom image classifier with a 5-flower database. And you learn about TensorFlow, how to train a linear network, neural network, and the DNN. And Module 3 also discuss dropout and batch normalization. So for those of you who are new to this whole thing of deep learning, these are some of the basics of like dropout and batch normalization. And Module 4 talks about how to use CNN, convolutional neural network, and what makes it different, and the key CNN model parameters, filters, number of channels, kernel size, etc. Working with pooling layers and implementing CNN on Vertex with pre-built TensorFlow container using Vertex Workbench. I just want to mention, like, when I started getting to AI and machine learning back in 2016, CNN was like the most popular, perhaps the only way to do computer vision. But today there's like vision transformer, like transformer really plays a big role, not just in large language model, but also start play a very important role in computer vision today. But this course gives you an intro to CNN when talking about computer vision. And then Module 5 talks about image data, pre-processing with Keras and TensorFlow dataset. If you start learning about the life cycle, right? To train a model, first you do pre-processing of image data. And earlier I was talking about the early module was talking about a image classifier using the 5-flowers data set. Well, you will notice a lot of these toy examples or data set on Kaggle, the data is already pretty much prepared for you. You just need to use it. But in the real world, when solving real world problems, you actually spend a lot of time on the data pre-processing, a lot of times more so than the model training part, right? You spend a lot of time on actually preparing the data. Then Module 5 also talks about the data scarcity problem. We don't always get enough data for training the machine learning model. How do you deal with the problem? Well, one technique is image augmentation. One thing I want to talk about image augmentation. You use Keras, TensorFlow, or these frameworks. They all have the standard image augmentation, right? You flip it and changing the data slightly to augment the data. But I also want to mention today with generative AI, a couple years ago, the synthetic data is probably not good enough for training. But today, synthetic data is actually pretty good enough for augmenting the data for model training. In fact, today we use ML to not just create a synthetic data, but also to do labeling, detection, or segmenting. First to actually prepare the data for some other task, ML tasks. And then the second technique for solving the data problem is transfer learning. And just want to briefly mention about transfer learning because it's such an important concept, right? So transfer learning, it really it allows us to train with less data and faster training and better result. And well, what is it, right? And for those of you who watched the Matrix movie, you see that he said, "I know Kung Fu." I think the knowledge got like transferred into his head. Because typically when you learn something, you take years of practicing, right? Whether it's playing piano or play some table tennis, it takes a long time. But this is just like boom, transfer it into your head. The transfer learning kind of works like that, but you can take the class and see the nitty gritty about how transfer learning works. Another analogy I would give you is like if you learn how to play tennis, you're really good at it, and then you want to learn table tennis, which is different, but some of the skill gets transferred over for you to quickly pick up that new skill, right? And transfer learning, it is very important, and it's also what enables a lot of the, today we use these foundation models, right? And one of the techniques is also use transfer learning fine tuning. So I went through what is covered in the course. The course on the Cloud Skills Boost cover the Cloud Vision API and AutoML Vision in depth, and also give you these hands-on labs, right? But I also want to mention some other Google Cloud APIs that are available out there. For example, the video intelligence, and then also the document AI, the API, beyond just the vision and auto ML. And then finally, very, very important on Vertex AI, the Gemini, since we're talking about computer vision here, Gemini Pro Vision, and also Imagine 2. And Gemini Pro Vision is able to do visual analysis, not just on images, but also on video and multimodal question and answer and analyzing the media. Imagine 2 allows image generation. For those of you who have tried like Midjourney or DALL-E, through ChatGPT, and the various image generators. So Imagine 2 works similarly and able to generate images. It also allows you to edit images. You can select the background and only change the background. You can select part of the image and make changes. And it also allows visual captioning. Captioning is like you give it an image and it describes the image in a short sentence or very elaborate in a long sentence. And the visual Q&A allows you to actually ask questions about the image. So yeah, I thought I'd just point out Gemini since the course did not mention that. And if you wish to learn more about Gemini Pro Vision, Imagine 2, a couple ways that y'all have access to the Cloud Skills Boost course there, and we're here studying for MLE certificate, right? The MLE learning path. But on the Cloud Skills Boost platform, you can also find generative AI learning paths. There's one like a really simple and intro one, and there's a more advanced one geared towards developers. I often also talk about generative AI and one of which will be using Google Cloud. Like, for example, I'll be going to give a talk on Cloud Next, and I'll be talking about it then. I will also be talking about a lot about these generative AI with Google Cloud when I go to the Build with AI conference organized by GDG Surrey. And then GDG Seattle is also organizing a Build with AI, and we will have a series of study series likely focusing on generative AI. And like I said, my passion, art and design, a lot of focus is very visual. So with that, I wrap up my part on computer vision. I will hand it to Vikram for the production ML systems. And I'm going to stop sharing now.
Thank you, Margaret. Before we move on, let me quickly introduce Vikram. I hope you can see my screen. Perfect. Thank you, Margaret, for such a lovely walkthrough of the content on computer vision, and also giving those amazing examples with the visuals. So we welcome Vikram now, and Vikram would be talking about production ML in this session. He's a co-founder at Omni Labs Inc., where he helps building the future of the work, how he calls it. And he's a Google developer expert. He's expert at Google Cloud. And again, machine learning expert we have. And he's helping others building the learning and building and excelling the machine learning products at Omni Labs. So let's have this platform, give this platform to production ML systems by Vikram Tiwari. Thank you. Over to you. Did we lose Vikram?
Vikram got moved out of the speaker room. Oh, okay, he's back.
He's the presenter. Do you?
Are you able to present, Vikram?
Oh, let me connect.
You can move me out if, in case you have a quota. Do you have like a set quota of how many people?
No, actually, no.
Okay.
This should work. I suspect it's just a network issue because he's like dropping. Let me ask.
By the way, while Pretty is Pretty and Vikram are dealing with technical issues, I just want to say a few words about Vikram. And we have known each other for so long, and he has given a lot of talks at our GDG Seattle. Hello, Vikram. He's back.
Hey. All right, let me see. Just 1 second.
Yeah.
All right, there we go.
Yeah, perfect.
All right, let's do this slideshow. All right, hello, everybody. Hope you are doing good while things are loading. Okay, hi, my name is Vikram. I've been running Omni Labs for a while. Margaret was mentioning I've been speaking at different events as well. I love to do these more in person rather than on call, and that's why all the technical issues don't like them at all. But thank you all for joining us today here. I know it's, for some people joining from India, it's very late for you. For people joining from all over the world, it's like sunny day in California, at least. I know you're missing out on some stuff, but I'm glad that you're here and learning together with each other. So I'm going to keep going forward, and please feel free to ask questions in the chat. I like to do more Q&A rather than more the presentation, so feel free to ask more questions, and hopefully I can answer them at the end of this. I have a very short presentation, so hopefully we have enough time. All right, so before we talk about production machine learning, the first thing to note is production machine learning is hard. So as you're going through the classes today, if you feel like you don't understand something, don't worry about it. Most of the machine learning, when we talk about machine learning, people think of it in the terms of algorithms. But what ends up happening is that machine learning engineering is only 10% of machine learning. Rest of it is actually engineering. So this is my friend Chip, and she tweeted this, and Elon responded for that, which is very interesting. But that's the truth of it, is the amount of machine learning that goes into a machine learning system or an app or something else that you're seeing in the wild, it's actually very small compared to the rest of the system that is there to support it. And the better, this slide has been a lot overused, but this is what it looks like generally. You have systems which will collect the data, they'll clean up the data. You have to figure out how to even manage machines, because there's so many machines that you have to run training upon, especially with Gen AI models. There's like the machines, number of machines is too long. If anybody read the Gemini paper, they were talking about how, I don't know, like suns flares up, which causes CPUs to, for the bytes to change within the CPUs, which causes the model to not learn well. So they have to account for that when they're training models of this size like Gemini. So things like that are like, I don't know if machine learning people who are doing core machine learning are thinking about that. At least I'm not thinking about that generally. Uh, but when you're trying to build a complete machine learning system, you have to think about all of those things because they affect the whole system. Because doesn't matter how good your model is, if it can't have good inputs, if it does not provide the outputs, if the outputs are not timely, if they're slow. We all seen this, like where people or companies would put a lot of effort into building something, and when they launch it, they probably miss something specific. It could be latency, it could be the training on adversarial data, it could be something else. But those things end up causing issues where the public perception of the model itself is not good. But model itself also is like a very small part of it. It's the whole system that probably is not behaving the way the builders of the system intended to. So let's actually talk about who are these people. So in machine learning lifecycle, I like to think about them as these different groups of people. Sometimes there will be one individual who will be combining these 2 3 different roles. Sometimes there will be like even more fragmentation within these. Like there could be data analysts who are working for more business side of things versus more for the internal team, finding out different analysis, different things that they could be doing with clients and stuff like that. So there's like different groups of people, and their jobs also differ, which means their incentives differ. Where machine learning engineer, they are only concerned about a model when it's in production, versus data engineer care about getting the data clean and making it useful for the machine learning engineer. So these groups also need to talk to each other, because if they don't talk to each other, then the machine learning engineer who's expecting a data in one format ends up getting, like, let's say 512 plus 512 images, they end up getting 256 plus 256 images, and then the model doesn't train. So they have to go back and talk to the data engineer. So there's a lot of things that end up happening across these people. Sometimes that's where the problem lies, and that's like one of the things that I like to talk about a lot, is like more often than not your problem is less about this computer science and more about the people. So just being aware of that is very helpful when you are starting to think about problems or starting to work upon a machine learning system. And now all of these groups of people have their own different unique things that they generally do. So here I have talked about, I have added like platform productions in here, like actual platforms on Google Cloud that you can use, that these people might be able to use to run their workloads. But it could be as simple as a product manager looking for insights and objectives on an interactive BI, which is Looker from Google side. Or they could be just doing this on a spreadsheet. You will see spreadsheets actually go across this platform from time to time, where a data scientist might actually work on spreadsheet for model evaluation and selection, and like machine learning engineer might be tracking their machine learning metadata in a spreadsheet. So forget about spreadsheet because they work across everything. But other tools that are around here are very unique and very useful. And as you go through the material today, you will find that most of these tools, how uniquely they help in specific tasks. You will learn more about the problems, and hopefully I can give you a quick intro around what those problems look like. So as you see in here, today, or this section at least, will be focused more on machine learning engineer rather than machine learning developer or data scientist. Margaret talked to you more about things that fall under machine learning developers purview, where you're trying to build a model, trying to build an intelligent app around the vision systems, So it could be like getting the data and using a transfer learning to build a model specific for your use case from a bigger model. But now, once you're ready with that model, you could pass it along to machine learning engineering, or you could be the one who's actually doing that process to put it into production and actually start using that for your app or whatever you're trying to build. So this is different groups of tasks, different groups doing different tasks, but generally you have to do all of these to get to a system that actually works well. Now, the other problem in this machine learning lifecycle is the infrastructure itself. Most of the time, or as I'm seeing, this is my purview, my view of the world, where when I'm looking at the world, I see there's a lot of people and lot of these resources that are out there, where there's notebooks that you can run on Colab, or you can run them on Kaggle, or you can run them on Hugging Face. And there's a lot of those where people come in, they can do exploration, they can try out a model that is on Hugging Face or Kaggle, and they can run that model for their own use case and try it out and see how it works, and just some basic experimentation in there. But once you have built that experimentation, then you need to actually be able to train it on your data. And now I have this here, local machine versus VM. Sometimes the models don't fit on your local machines. You might not have 10 GPUs running on your machine. Hopefully nobody has 10 GPUs running on their local machine. Hopefully they use cloud for that. But that's where it comes in, where you pass this development phase where you're actually iterating on the model multiple times. So in the first phase, you could figure out, hey, this kind of model, or let's say in the image case, we are there. Let's say Imagen, that is the model from Google. I don't think they have released the model itself, but let's say they release the model and you really like that model. And in the Colab notebook, you are able to get to, hey, yeah, this model works for us. We might be like, it has enough classes that we are looking for classification, or it can generate what I'm looking for image generation. And then you pass it along to building it on top of it. Now you want to figure out, hey, there's specific retraining that we might want to do in here, or something else. But this is where you actually build the whole model and get it ready for production. Once the model is ready for production, you pass it along. And these two things will happen quite often. Actually, all three of these happen back and forth. But once you pass it along to the cloud side, that's where you have to take this model and deploy it onto cloud. And this deployment is not one time. Most often people think about, when we talk about deploying things, it's same as code. You don't deploy code one time and forget about it. You keep iterating on it. You keep building things. You keep finding bugs. And whenever those things happen, this whole cycle repeats itself. And this means that anything that you're doing has to be scalable down on a small notebook where the resources are very few, to the cloud as well, where it can easily scale out. And you will find, as you go through the sources of the tutorial today, that there are machine learning packages that we use for these, or specific components that we are using, like TFX or Airflow or something like that, where it can take something that works on your local machine and still scale it out on a large cloud server group, or whatever you want to call it. The other big challenge in here is the machine learning lifecycle is the data. So data and skew and drift. So those are like similar-ish concept, but they are kind of silent killers for your machine learning model. So let's say today you trained a model on banana. You're trying to identify banana, but you trained your model on the green banana. But when you actually start production and the banana becomes yellow, and now your model doesn't recognize banana, but because for the model, banana is green. And over time, the banana decays into something else. So that's called training serving skew, where the training time had the banana in green, but in the serving time, when people are trying to actually use the model, the banana is actually yellow. And then prediction drift is happening, is like, it's green to yellow. It's like prediction does not change. Prediction stays on to green. Or sometimes I'm trying to think of this as like, okay, another group example in a much larger sense would be when we segment population into different age groups. But over time, if you don't update your models, the things that 18 to 20 years, 18 to 25 were interested in are suddenly now 25 to 35 group. They are interested in this because people have moved on, people have aged, and they are now in a different age. The things that they liked at that time are still the same. It's just your class is looking at 18 to 25. You need to update that label because those people have aged now. It's 25 to 35, whatever that age group is. So those are the kind of things that you have to continuously retrain your model on. I gave you this a very long example 5 years later or 10 years later, but generally it happens very often where you will see that machine learning models are iterated on a daily basis, or if not daily, like at least weekly basis, where some things happen, things change, weather prediction, or there's a lot like music. There's the other one where you need to figure out from the audio coming in, you need to figure out what kind of or who's the artist. And for that, there's so much music getting released every day. You need to be able to update your model so that you can account for the new music that's getting released. So that's the drift that happens, and you need to be aware of it. And that means you have to continuously retrain your model and check against it. This is the big thing that happens in generally is like we will see that amazing thing got released in research, but there's a long time before that gets actually put into production. So early, there's like this thing that happened in machine learning, which is the machine learning venture, where in 1990s or sometime that time, we had all the things that we would need to be able to build really good models. Those are the concepts that we used in like past few years to build the models, but we did not have the compute. So research was actually very excited. Research groups were very excited because they were finally able to prove that, hey, we can learn from images, but we did not have enough compute to actually put it into production. Uh, Similarly, there's like a lot of other things that happen where like in doing research, you have fast training. You focus upon fast training and high throughput. So you want to be able to go through your iterations quickly. But on production side, the whole thing changes on it. Like you don't care about fast training. You care about inference. You care about how quickly can model reply to a query that is coming from the user and that latency. Um, Research data is generally static. Like I know people have been using IMDb data set for forever now. IMDb and like the Titanic sunk years ago, and we are still using that data for research stuff. Or research stuff for like toy examples, not research, but toy examples. But for production, it's constantly shifting. Like today, the data that you're getting will be very different from data that you get tomorrow. Fairness, it's sad that it's like not as important for models generally to have fairness and those kind of things, but teams are working on it, but it's still good to have. But in production, it's very important because you can't release a model that is not fair to different groups of people or different segments of audience or different segments of classes. These models are accessed by users, but sometimes these models are getting deployed on a factory line where they are trying to figure out defects into the chips or whatever the manufacturing is doing. And if they are not fair, where they are only looking for a specific type of fractures or defects, but not other types, they are not looking at the overall picture. Let's say they are only zooming in on defects, but the production line was supposed to produce phones and they are producing mouse, then it does not work at all. Um, Similarly, interpretability. Uh, it's good to have those things when you are doing research, but it's very important in production. Think of a use case of a bank denying somebody a loan, and now you have to figure out exactly why a machine learning model decided to do that. And it's very important. You can't go to production without those things. So the objectives between research and production differ. And that's why generally when we see around in the world a lot of models being used and you see them excited, like you get excited and you start to think about how do I put it in production. There's a lot more different things that you have to think about before you can actually take it into production and start using it. So this is what it generally looks like in a production run. This is a very simple toy example where this is, I think, an image-based model where it takes the flowers, and this is using TFX on Google Cloud, where it's importing the flowers. So these are the examples. There's like two different trainers that are happening. So you generally won't be playing around with just one model. You'll probably have multiple different models that you'll be training upon. So there's a two different models training happening, DenseNet and MobileNet here. They're training the model, they get the model, then they once they have the model trained, then they push it to Google Cloud and save it somewhere, and then they upload it to Vertex as well, where it gets deployed as an endpoint. So this is a complete life cycle on here. Same on the other side. On this side, it seems like the model is getting, this is mobile-based model. So this is a bigger size model which runs on server side. This is Vertex AI's Vertex is server. On the mobile net, this is a smaller model. Same data, but being trained for a smaller model, because this goes actually on to Firebase, which means it's going on to the end user device. So this pushes the model to user's device. So this is what production challenges look like. And this is a very simplified version of an example. But when you go into production, you will see there's a lot of these things happening, which means you need to have visibility into every one of those components. Like right here, it's like it's getting deployed onto the Vertex one. It's not done yet. Or similarly here, it's like being uploaded. This step has not even executed. This is the one where it's processing right now. Sometimes you will find that, hey, the API has gone to rate limit, nothing to do with your machine learning model, but the API is rate limited and you can't deploy, you can't push it to somewhere else. Or this here, like the file-based publisher, you uploaded everything in there, but the sync is not happening as often. Or let's say something misconfiguration happened, and it's not getting deployed to users' devices. Something else is happening. So all these things are different things that you need to be aware of in production. Thankfully, today you have a course which will guide you through almost all of these things, which go through architecting a production machine learning system, designing such an adaptable machine learning system, because you will always have problems. People who go with ideal systems where nothing will break ever, it breaks. There's no such thing as nothing will break ever. So you have to build your systems adaptable so that when you encounter problems, you can use those to fix. You should be able to fix those problems quickly. And then you have to worry about high performance, because yeah, today you might release a model that generates memes, but 10 days later you might end up becoming the meme company. And that means that you have to have high performance on these machine learning models. People will expect your memes to be generated fast. And then finally, of course, you have to think about hybrid machine learning systems. Let's say you are generating memes on server, but now people want this on their phone. So you have to think about how to build your services for different groups of people, where they are accessing it on a server side through a website or something, or an API, versus people accessing them on their own device, or even taking that further, putting them into IoT devices. And I'm thinking Times Square. Why not? In the Times Square, there is a TV where it's being generated on Raspberry Pi and being shown to the world. I just want to call out this. Most of the context that I took is from Chips and Anis's slides. They are amazing friends, and they are one of the few experts onto production machine learning system. Feel free to follow them, or you should follow them on Twitter. And I think that's it for me. Hopefully, as you go through the production machine learning system, you come out with having a much deeper understanding. Another thing I want to call out here is most of the other things that you have gone through this in this lab in machine learning journey for you. Those are amazing, because those are good and amazing because they help you get a good understanding of it. But this one is very unique because more often than not, you will not see these problems unless you are working in a corporation which actually deploys models to production. So for most people, this is their first time getting into a place where they can actually play around with production systems or compute that is actually good, high level, big servers compute. So please feel free to, like, even after you are done with your lab, if there's time remaining, feel free to poke around things. Try to see what you can do, what you can break, or why it works the way it works. I hope like everybody gets a good time here, and feel free to ask me questions. That's it from me.
Gets us started and sets the expectations right. Thank you, both of you. I'm going to share the Q&A slide so we can take the questions. And there we go. I hope you can see the questions. Okay. So maybe we can get started with the first one. I think this is for Margaret. How much custom programming, example Python coding, is required for modules 3 to 5?
I think you will need to have like basic programming, Python coding to learn machine learning. But if you are looking to some of the Google Cloud tools, it's just a API call. Like, you're not doing machine learning training, you're just doing the API call, then you don't really need to know Python coding.
Right. Thank you. And the next one, in general, how does machine learning development lifecycle differ from software development lifecycle?
I can take this one. So just to talk about like basics in here. Generally, when you are building software, you think of limits as something that you will rarely hit. And to give an example, it could be when your system scales, then you will run into the RAM limit or the CPU is going 100% or things like that. But with machine learning, that's very often, very common, where every time you try to train a model, it will very quickly run into not enough memory. And like it happens all the time on Colab, or if you're not a paid user where you're getting smaller GPUs or not even using GPUs, that will happen more often than not. So that's like one of the biggest problems that people have. But then there are silent problems. Like generally in normal software development lifecycle, you have edge cases that you find out, and they are generally easier to debug because you can put or write unit tests, or you can reason about system going from one point to another. You can put debug trace logs and stuff like that to see how is data or a query going through your normal software cycle. But when it comes to machine learning, all of this becomes much, much harder because, to give an example, there could be an image of a panda, but this time the panda was wearing a costume. So when you costume in brown color, so next time during inference you see image comes in of a bear and it labels it as panda, and you're trying to figure out why is it doing that, you will have to go through your whole life cycle of the model to find that one image that's somewhere in your model, which is a panda wearing a costume of a brown color. Uh, that's like a very simplistic example, but you will find similar problems happen all the time, where there's some unique thing that is in your data that you didn't look for, which model learned, and now it's behaving very differently versus what it would have behaved in a normal way that you were expecting it to behave. So those kind of problems are like kind of harder to find out. And the other part in here is also like even the lineage of this is like, since data comes in every few days. So for an example, let's say you are a self-driving car and you get retrained on the data that you collected every day. Now, even to figure out why car is turning left on this sideway every time, you have to go through, let's say, last 30 days of data and find out all the different segments where it might be happening, but it might not be even there. You might not be able to find the data for last 30 days. We think of these systems as like they're very well built and I can find exact timestamp because we're used to seeing those CSI stuff, but it's not that easy. Like the data is all over the place. You will have like 30 minutes spent in there just to find that one source of data that might be causing this. And then to fix that is even a bigger problem. Like you have to retrain the model from the scratch. It's not that you just make a bug fix and it works. You make a model change. Let's say that panda image, you take the panda image out of your data set. Now suddenly your bear classification is not working well. Nothing to do with the thing that you're working on. You improved the panda classification, but bear classification is not working well now. Now you have to add more classes for the bear and more images for it or more different variations for it. So these kind of problems are the ones that can cause unintended side effects, and that makes it harder for the whole life cycle to work. But yeah, like it's a totally different way to think about the problems, because one is you know exactly what the things are doing because you have written the code, you can see it, versus the other side is a learning thing, and it depends upon the data. So what it's learning, you have to have good understanding of what it's learning, and there are tools around this where it can tell you, hey, you have a class imbalance, you have a lot more images of this type of data versus very few images of this type of data, so your model might not learn these specific things. But this is a different way of thinking about that. Sorry for the long answer, but yeah.
Well, this is great. I mean, it took me back to when I started with the Colab, and it was always like out of memory because of maybe the bigger data set or number of epochs that we have, and I just that time I just didn't know like what to do. We were going through all the Google answers, and reaching out to professors, but I think that's pretty normal. Like that's how you get started. That's how you start learning. What's the difference between a software development lifecycle? You can see clearly, you can debug it, and then versus machine learning. Thank you for that answer. Next one, is facial recognition a popular use case of computer vision as well?
Yes, it is. I mentioned earlier about module 1 actually uses the vision API for face detection. And for faces, you can detect if there's a human face, and also you can detect the boundary of the face or specific landmarks like eyes and nose and mouth in the face. And then another one is, instead of just say is there a face or not, you actually say, okay, is that Margaret or is that Vikram? Like ID, right? You're matching. Typically, you have to have a database of the known faces to do that matching.
Perfect. Thank you. I think the next one is also for you. Link to your blog, please.
Yeah, sure. So I'm gonna put my link to blog in the chat, and I would say if you go to my website, yeah, I'll put it there, margaretmz.art. That's my main website. On the top right corner, there's link to my LinkedIn, Twitter, artwork, and everything. So thank you for asking.
Perfect. How does generative AI influence the more traditional computer vision, such as CNN?
Okay, that is a very interesting question. I'm not entirely sure about the word influencing, but let me just talk a little bit of the timeline of generative AI. Generative AI, I have been talking about generative AI for a long time. Even up until 2021, the most popular models were all GANs, generative adversarial networks, and there's just like a whole different type of GAN models. Of course, there are other generative models too, but GANs was like really dominant. And since the August 2022, Stability AI released the state open, what is it called? Anyway, diffusion model became really popular since Stable Diffusion was released. And then ChatGPT by OpenAI in December of 2022. I view those two as the catalyst of today's generative AI. You call it hype or popularity? Anyway, before that, I give a lot of talks on generative models, generative AI, but typically you don't hear a whole lot about it until end of 2022. Now everybody thinks that everything is generative AI. Well, not all. Some of the computer vision problems I talk about, of course, classification is like really basic, but object detection and segmentation is quite important. Pose detection, like in self-driving cars, a lot of these detecting, pretend your car can see everything, right? So vision is very, very important. But to answer your question about the CNN part, I also mentioned in my talk earlier is that also up until recently, when you talk about computer vision, it's all about CNN, right? But today, a lot of the models like vision transformer and then we have diffusion model, but now the new models is also use instead of using UNet and actually use transformer for these generative new models for going from text to image and like Sora. Okay, yeah, I think I answered that question.
Thank you. Next one is, how is image augmentation similar to synthetic data?
So image augmentation, as I mentioned earlier, there are some very standard techniques, right, to try to increase the diversity of your training data by do some random cropping, flipping, scaling, translation, and rotation. All of these you can find in Keras, TensorFlow, PyTorch, whatever framework that you are using, right? You're just doing some adjustments to the data so that the data is more diverse. But another thing is synthetic data, you're actually using generative models to create data. So instead of collecting data with camera and labeling it or scanned images. Now these images, synthetic data, are actually generated by machine learning models. So I would consider that as a image augmentation technique as well.
Perfect. Next one is time. Okay, time permitting. Can you talk a bit more about the class you will be teaching? Will it be hybrid, online, or in person?
Is that for me? That question for me?
Yeah.
I think so.
Oh, okay.
Any class?
Okay. So I heard the class. There are a couple of things. Sorry, I didn't put it on my slides. I said the word class. So I will actually be an instructor at the University of Washington, Foster School of Business. I will be teaching a course. The formal name is called the MSIS, AI and the Machine Learning for Business Applications. But the actual curriculum that I will be doing is there will be a lot of generative AI and in business application, of course, hands-on as well. That course is only for the grad students at the Foster School of Business. So that's one that's not accessible to everyone. But another part is that GDG has this Build with the AI campaign. Like, for example, GDG survey pretty is organizing one on April 20th. Near survey or British Vancouver, right? That's an in-person one. And for your event, you started with this MLE online series in collaboration with GDG Seattle, and then you kind of wrap it up with that Build with AI in person, right? For GDG Seattle, we are going to kick off the in-person event of Build with AI early May. And then after that, we're thinking of a series of online sessions, kind of like this, except this is MLE certificate, right? Google Cloud. But those sessions will be most likely we will use the generative AI learning path from the Google Skills Cloud Skills Boost. And there are two courses. One is more of an intro. Another one is more advanced towards advanced learner developer. So I was thinking of running those through online, and those will be accessible to everyone, just like this study series.
Does synthetic data reinforce biases inherent in the core data?
Yes, I think that's probably one of the problems with using synthetic data. So in the data collection or curation process, and you have to be careful in putting together the data, just like when you collect the real world data as well. You have to worry about the class imbalanced data, as well.
Awesome. I think the next one, I believe, is for Vikram. Is that diagram available for reference? I believe the one you shared with production ML, in one diagram.
Yeah. I think the slides are shared, but if not, feel free to share those. No issues.
Perfect. Next one, can we use CPUs for run these stable diffusion models for fun? Okay.
I think Vikram earlier shared in Vikram's slides, Vikram talked about collab on your computer and cloud, right? Those are the options. For stable diffusion models, I am not sure, but I know Gemma, which is not, because stable diffusion models are still, a lot of it's focusing on the visual part, right? And Gemma is only text in English, but it's generative model. That one can run on CPU, right, Vikram?
Yeah, I actually don't know. I don't see the problem is running. So, okay, to answer the question, yes, you can run most of these models on CPU. The problem will happen is the model, you will have to do few things to the model. One is you'll have to quantize the model, which means these models are generally trained upon 16-bit or floating point information, which means when the model Generally, what the model looks like when you look at a model file, it's just a lot of numbers. But these numbers go from 0 to 1. That means 0 dot, and then number of floating point digits, numbers after that. So what you can do is you can do quantization, which means reducing the specificity of these numbers. So rather than having 0.111111, you just go for 0.1. That reduces the size of the model. So when you reduce the model size, that means when you do inference, your inference goes faster. So the answer to that question is yes, you can use CPUs to do these models, but they're not going to be the same models, because think of a model has 99% accuracy. That accuracy comes from the model having such high specificity in the model itself. But if you reduce that, that accuracy will go down. So that's why generally what ends up happening is the models that are on mobile don't perform as fast or as accurate as actually, I would take that back. As accurate. Fast is unique to what compute they're running on. But yeah, that's what it is. So yes, the answer is yes, but you might have to find the exact model that somebody on Hugging Face might have uploaded for you to use.
I guess, thank you so much for answering that question. I guess my question is a little bigger and it runs out of characters. I'd rather ask it. I'd rather.
Yeah.
Yeah. So my question is, because we were talking about machine learning, life cycle. So we have advanced techniques like few shot learning, one shot learning, and like sophisticated prompt engineering in AI. So is there still a need to prioritize data quality and quantity both? And if so, then why? I mean, what I know from, let's say, zero shot learning, that you don't really have to provide any data in it, because it already have built up some knowledge. So do we still think that providing like some kind of similar data, even if it is generic model, do we still need to quantify the data and look at the quality?
So I think to answer that question, we have to go a little bit back. The kind of models that we are talking about right now are generative AI models, which work because they have been trained upon a very large set of data. These models by themselves would not be able to perform the way they perform if there was not enough data. So if your goal, so the way I would think about these problems is today would be, if you see an openly available model that is out there, and if you can use one shot, few shot, or better prompting to make that model work for your use case, then you should never have to think about machine learning, because that's all very simple day-to-day programming. You can do all of that without having to worry about building a model. But if we were to come to a point where now you want to, rather than calling, so let me give an example right here. So if you were to use Gemini, I'm assuming the latency is going to be somewhere close to 200 ms, because you take a picture, you upload it into Google storage, call that API, get the response. It could be reduced. I don't know. I've not tried it, so I don't know the number, but there's some latency. But what if you wanted to take that model and put it on end user device? I know there's like they're releasing a smaller model for Gemini as well, but if you wanted to build your own model, for that you will need your own data. So in short, I don't think that that problem is ever going away. Large companies like Google and everybody else, you keep seeing in the news where they are doing partnerships with other companies. Like Google recently did a partnership with Stack Overflow to get a lot of data around programming, because they can use that to build their models better. That is not going away. Like, I think we will always have the need for good, curated, large sets of data. But what might happen is, for a lot of use cases, you might be able to take one of these off-the-shelf models and start using them. So for a lot of use cases, it might not be a problem.
Yeah, I also want to add to that. I'm gonna send a link. I'll put it in the chat. It's my sketch note from a couple of years ago, 3 years ago. Wow. So there was this talk by Andrew Ng, ML Ops from model-centric to data-centric AI, which is a really good talk. He really focused on like, mentioned it earlier, a lot of times when you are doing ML, like when you're doing toy example of image classification with 5 flowers data, the code is mostly training the model, the architecture, blah, blah, blah. You don't worry much about the data, right? But in the real world, like the machine learning, like production machine learning, 𝗏𝗏𝗃 is talking about when you solve a real world problem, a lot of times your time is actually spent on data. Now, in the talk about Andrew, he actually talks about big data versus good data. He said good data is much more important than big data. You don't necessarily always need like the big data to train. But on the other hand, those foundation models like Vikram talked about, yes, absolutely. Only the big companies like Google has ton of these YouTube data, right? Um, they can afford to have those data to train. But I also talked about transfer learning. That's actually also very good for just fine tuning some of the already pre-trained models, right? And then you don't need a whole lot of data.
Awesome. I think, yeah, that clears a doubt. And I'm going to follow the LinkedIn post that you share. I'm going to check out that particular mention. With that, I have more curiosity for, like, I'll ask maybe after this question that we have on the screen. I'm not sure. Can we schedule a break in March to align with school holidays and community observances? Also a chance to catch up. Is it for the road to Google developer certification next year, or I'm sorry if you could elaborate maybe in chat or another Q&A drop.
When is the next session? The next session is for the MLE. The next session is on
23rd.
23rd, and then after
next
that
week.
it's April 6th. Is that kind of a gap between your school break? Or like going from 22nd to April 6th?
Okay, I have no clue about the school holidays somehow, yeah. But we can, I mean, right now, if it is about current sessions, then we already have our instructors, they are already, like, they have given their schedule, they have confirmed their schedule for these particular dates. And it may or may not be possible to move them depending on their availability. But we can always, check before coming up with these events. We can always check from next time onwards to see if there are any holidays and if we could move it towards the holidays, or just to make it easier for you all to join. With this particular one, we came up with Saturdays because it was, Saturday was like happy weekend, because on Sundays we start thinking about that, okay, we have to go to work on Monday, so we still want to relax on Sunday. We don't want to do much and we want to spend it with our family. So we thought, okay, Saturday would be a happy spot, but we'll consider from next time onwards whatever we could do to make it easier for you to join.
Also, we would like you to finish these courses before you come to the session. However, if you don't finish it, or even if you have not started, it's okay, because I hope you find these reviews, or short talks by me and by Vikram and other speakers help to give you that overview, right? Even if you have not started yet.
Right. Thank you. I think we have this one more. Margaret, how do I know if I have good data? Where can somebody find a good data set for training to learn?
That I think that is a difficult question to answer if you know you have good data. Like data quality, it depends on what tasks that you are training your machine learning model for, because there's also metrics to measure your ML model, right? To how your ML model is performing. That could also be one indication of maybe your data wasn't good for training the model to begin with, aside from the model architecture, right? Also, if if you have good data or not, yeah, like I said, it when you are measuring your model, let's say your model accuracy or etc., that's one indication. And another thing is data, it has different types. There's structured data and then unstructured data, right? So structured data would be like rows and columns, like like in the spreadsheet in the database. For those kind of structured data, and to identify whether or not the data is good, you can look for duplicates, dedupe. You can look for missing data. But for structured data, unstructured data, say images or videos, etc., some of the good or not either could be based on visually identifying with human judges and human um, uh, labeling. But another one is you could start using machine learning model to evaluate whether the data is good or not. But then you have to set up the matrix, right, first. Then you know if it's good or not. Like you have to set up some bars for your specific scenario. Vikram, do you have anything to add? And another thing is, like, a lot of times people are talking about the bias, right? So depending on what you're doing, if to give an example, for example, if I'm generating faces or I'm doing some sort of style, etc., and then if the data does not have a good variety, or certain category is not type is not generating, or for example, it's only generating female or male or ethnicity, etc., there's a lot of consideration. And anyway, I don't want to mention some other controversy, recent controversial thing too. It could be very much depending on, there's a lot of debate on the recent controversy show things of, some historical events, the faces generated or actually not the right ethnicity, etc. Well, it could be a data problem. It could also be how you're setting your bar for whatever the responsible AI you want to be, right? So I hope I answer your question. And then Vikram, you have anything to add?
Yeah, just one thing I would add is, like, if you are playing around with data, it doesn't matter. Like, you can find a lot of data in a lot of different places. I linked dataset research.google.com. It essentially aggregates data from all the different resources. You could find it on Hugging Face, Kaggle, XYZ other locations. So if you're just trying to learn and play around, that does not matter. But as you start building your models for production, it will matter quite a lot on where you find the data, how you are curating it, all the different fairness things that you will have to think about in there. Does it sample? Does it reflect the audiences that are going to be using the data? Does it have all the different themes encapsulated in it? So all the things that Margaret mentioned, you will have to be aware of all of those things. So generally what I say is, for training or for just playing around with things does not matter. You will find a lot of data sets that you can use for just playing around. But for production, you will have to do lot more on data, because that essentially is the foundation for your machine learning model. Garbage in, garbage out, we talk about that, and that's easy to find and fix. But more often, it's subtle differences, subtle things that are happening in your data that you just end up spending a lot of time to find, fix, and they take up a lot of time on your team side, but also you end up losing a lot of social value around that as well. Let's say you released a model which was not good at certain tasks and then becomes a social media thing. Those things are not good. So yeah.
I think we have another question dropping in. Are all session recordings available on YouTube? Yes, they are. But like after this session is done, we wait till Wednesday and Thursday as the team, have more time. They try to put it on YouTube, but you'll see it within a week after it is complete. And you can also find it on the official page where you RSVP for your next event. So if you go to the past events, you'll find those recording links there too. Okay, I believe this is all in the Q&A, but we still have time. So
I think someone was asking me a question about how to become part of Google Summer of Code. So I just text the timeline into the chat. So there's the deadline. Let's see, when is the deadline? Contributor application deadline is April 2nd. So look through the detailed timeline, but April 2nd is you have to get everything done. And basically, I was a mentor. I was involved into both the selection process as well as the mentoring process. And in the selection process, you really have to be, your project needs to stand out, right? And also Google Summer of Code is not just about TensorFlow or a particular technology. There's actually, I don't know, like hundreds of orgs in there, depending on your area of interest that you can participate. And it's a great experience. If you do participate, you get paid and you get mentors to help you.
Showcasing projects and mentors. Okay, so moving forward, let me double check for the questions. No more questions there. Thank you, Vikram and Margaret, for answering all these questions. They were really detailed, and of course, the content overview is always great for all of us who are preparing for the machine learning certification. They give us a Kickstarter, and and as I mentioned earlier, if I'm like with Margaret, we are continuously in touch. So if there is any question, me, Vikram, Margaret, other team members, we all are here to answer in Discord. If you put your questions in Discord after this session, and for any other session 1 till here for the labs. The next session will be happening on March 23rd, and NLP, basically module-wise NLP and recommendation system is what we'll be focusing on. We have a special addition there. Raghvendra will be joining us from Singapore virtually, and he'll be talking about RAG chatbot development. He has been helping, his domain is in the enterprise. He has been over 20 years, he has been working, with generative AI products in enterprise setting. And then we have Chen Chang. She's an expertise in LLM and AI safety, so she'll be giving the content overview on NLP and recommendation systems. That's for the next one, and please do RSVP. Please prepare yourselves with the number 9 and number 10 courses on NLP and recommendation system. They will help you with the entire preparation. Plus, you'll have your questions answered within the session. Now, before I actually move to the thank you part, I would like to share this particular screen and encourage you to share your Google Cloud Skill Boost profile. We have linked we have a link in the chat we provided within the document where you could share your profile, and we would integrate it with our platform here, and then we can track your progress on courses. So like in my case, I have just I'm about to complete it. Don't judge me, okay? So I'm about to complete the courses for session 1, for session 2. The feature engineering is still left. So to qualify for the vouchers, which is the good news, please go through all the courses and let us know your profile. We'll integrate it so that we can track your progress. We are on session 4. You can also access this particular link. I believe I already shared it in the document. And this particular platform is courtesy of our friend Roman from GDG Lawrence. So he'll be conducting a workshop at Build with AI. He is an expertise in Flutter. He's a Google developer expert. So with his courtesy, we are sharing that platform with you where we can track your progress. So please do update your links there.
Pretty, I have a question about the tracker. I just took your link and put it into my browser, and I see your progress. How do I see my progress? Or is it by GDG, or is it by person, a particular person?
So how it works is that there is a Excel sheet. I just shared the link. So there is a Excel sheet. So I take your profile URL, and I input it in Cloud Functions. So I update all the links, and then it shows everybody's, like, if I redeploy it and it shows everybody's progress. So it will be GDG SETI basically, inputting all.
But you can see everybody's progress. Everyone who has RSVP'd to the event, right?
Actually, you'll be able to see as well. Like once you share your profile with us, and then we'll update it. So as of now, it's just me. I have updated my profile there, but everybody can see. Yeah.
How do we share with you our profile? How? Which profile? Is that the developer profile? Or is it the Google Clouds, the Skills Boost profile?
The Skill Boost.
Oh, okay.
So let me share the exact sheet. So here's the exact sheet in the chat.
Yeah, I see that.
Yeah, I can share just now. So
yeah, if you could just share with us, like, what are you expecting each attendee to share with you their profile? Because I can go to my account, right, on the Cloud Skills Boost.google. I have my account, and then I can.
So let's say this is my profile. I just shared in the chat. This is my profile. This is the kind of, this is from Cloud Skill Boost. So this particular URL, if you share.
I see.
Yeah.
I see what you mean. Could you share your screen of the Google Cloud Skills Boost, and then just go to that profile tab, because otherwise people will not know what you're talking about.
Let me do that. Okay, I have like 1,000. Okay, so this is my profile, and here is where I find the URL. That's just like simplest way.
We could not see the top of your screen though. I see Google Cloud, but the tabs are cut off on the top.
So this is another way that you can share this profile. Do you see? I mean, is it visible?
Yes,
Yeah.
I can see the I can
Right.
go to the cloud skillsboost.google, and I see my icon to the right, and there's a profile tab, although that is missing from your screen. But I can go to the profile and see myself. And then after that, where do you go?
Okay, maybe I'll go to the default.
Because I don't know how you're sharing your screen. It's missing the top
Mhm.
tabs, like the dashboard, the path, and the explore,
I
and the
believe
profile and subscriptions.
that's the 𝗏𝗏 doing it. This platform, it's cutting off the. Let me try it again.
Are you which program are you on? Are you on the Google Cloud Skills Boost?
Yeah.
Or oh, okay.
So let me try like from here. So I go on Google.
Yeah.
I'm sharing in the
Yes.
chat. I
Now I
go
can
on
see
this
there's a
link.
profile tab, right? There's a dashboard and there's a profile tab. So
Right.
you want people to be
So
on the dashboard screen or the profile tab?
so you navigate to the profile,
Yep. Yep.
and this is the link that you share
Yeah.
with me. Your
So
profile.
something I'm gonna mention to the attendees, because I'm trying to make sure people know how to do this, right? When I go to my profile, it says your profile is not public and accessible. Make profile public. So people need to make their profile public, then they can grab that URL. Yeah. See,
Thank you.
like
Yeah,
mine
thank
is
you so
not.
much.
Okay, good.
Yeah, thank you
Now
so much
mystery
for
solved.
mentioning. Yeah. And yeah, having said that, when your profile is public, you share it with the with GDG study. This
Yeah.
platform would this platform that I showed you, the tracker. Anybody who has the link to this website, they'll be able to see your progress there. So basically, your profile is already public, and then this is also for everybody, the entire GDG study community or anybody who has access can see it. So if you're not comfortable, people looking at your progress, um, it's okay. We respect it, and you can keep it private. You can let us know through chat, like direct messages, that this is my profile. I don't want it to be public, and this is please go ahead. Uh, I would say maybe share your credentials at least in DM so that we can progress for the vouchers. Vouchers would to qualify for vouchers, we need your progress in courses.
Yeah, that's good to know. Glad
Yeah.
you got the vouchers.
Yeah. Yep. Yeah, had to do a lot of follow-ups, but yeah, finally got them. So yes, so I think this is all. Next Build with AI is on April 20th in person in Surrey. And if you're someone who can make it to Surrey area in British Columbia, please do. We have amazing sessions coming. Margaret will be there. Vikram, I would extend my invitation to you. If possible, please do visit. I'm not sure about Google I/O whether we'll be there or not, but I mean, I'll be there or not, but I would really appreciate GDG Surrey would really benefit, by having you here and sharing you with all attendees. So yes, any questions for us, please send in the chat. We still have 20 minutes, and we would love to hear.
We have 20 minutes. I thought this session ends at 12. Going from 10:30
Okay,
to
yeah.
12, right?
Okay, so something happened because I was considering 12:30, so I was taking my sweet time explaining. But yeah, then maybe we should take it.
But we had a great
Going.
time, definitely.
Yeah.
This has been great.
Yeah, I think I need another tea or coffee now. Okay. Okay. So everybody, please post your questions in the Discord. And it was lovely meeting both of you again, Margaret, Vikram. We should set up a meeting again, maybe more sessions in future. I'd love to see you.
Great. Thanks, everyone. Thank
Awesome.
you
Thanks,
for
everyone.
organizing, and nice to see you, Vikram. Thanks, everyone, for attending. Bye.
Great.
Bye-bye.